Okay, let us see how we go about this question here. Still is about horizontal projection. So a tennis ball is served horizontally with an initial speed of 21 meters per second from a height of 2.8 meters. By what distance does the ball clear a net 1 meter high straight drawn meter horizontally from the server? That means that when someone is serving, not tennis, when someone is serving, we assume that the height that the ball is to the ground is 2.8. Then the speed at which that ball is hit is going to be 21 meters per second. So we start by sketch. Let us do a simple sketch. Now I'm going to consider this is going to be the height of the server. Now this one is going to act as my ground. So from here up to there, it's going to be 2.8 meters up the ground there. Okay, so read as we progress. 20 meters, 21 meters per second. So this is the initial speed at which the ball is going to be projected. 21 meters per second. Okay, after that now, they're telling us that by what distance does the ball clear a net 1 meter high to 12 meters from the server? So we have a certain net, maybe here. This is going to act as our net. It's 12 meters, so from here, this is the server, 12 meters away from the server. But the height of this net here is 1 meter, like that. So now, remember when we serve this ball, is going, of course, we want it to hit the other side. That is how it's going to move. Until when? We know how we make a point. When it's there, when it's in that defined region. Now, they want us to get this height by which it clears the top of this net. So let me call this one W. Now, the idea is going to be very simple. We know this height, we know we want this. So now, when we get the height, when we get this height, it means that we shall know the height from here up to here. We shall get this minus the height. If I know this height from here, if I know this small height there. So if I get that height, it means I'll get this height minus 28, I'll be getting the remaining height. So what I will do, this plus this will be equal to that height. So meaning, let me first get this one, let me call it y from there up there. But the question is, how am I going to get the y? You see that this y is going to be in a vertical motion. So in our vertical motion, vertically, using our s equaling to ut plus a half at squared. Now, you see this is the distance I want, which is y. My y will be this distance here. Whenever we are having vertical, then the initial, we take it to this 0, then plus a half. Now acceleration is v, then t squared. We know our acceleration, but we need time. So our y, now how do we get time? It means that what time is it going to use? From here to here, it would have covered 12 meters. But what speed is it using? The speed it's using is 21 meters per second. So meaning, if I'm to get this now from here up to here, I'm covering the distance of 12 meters. But I have the speed, so I can get the time at which I'm going to cover that distance. So our time here will be given by the distance over the speed. The distance we are covering from here up to here is 12 over 21. By what? By 3. By 3 here 4. By 3 here 7 seconds. So meaning that our y here will be now a half 9.8 into 4 over 7 the whole square. And from there our y is going to be, so we have 4.9 times 16 divided by 49. So I'm getting 1.6 1.6 meters. So meaning from here up there is 1.6 meters. So implying that now, if from here up to here, let me call it Z. From there up there, let me call it Z up to down there. So it's like my Y, not that my Y plus Z would be equal to 2. My Y plus Z would be equal to 2.8. So my Z would be 2.8 minus 1.6. And so my Z here is going to be, on top up there we get 1.2 meters. So if my Z is 1.2 meters, and this Z will be W plus Y. And so our Z is equal to W plus 1. This W plus 1. So if I want W, I find that my W will be Z minus 1, which will be 1.2 minus a 1. So from there it's that my W is going to be 0.2 meters, and that will be the distance. So it will clear this at a distance of 0.2 meters. Then they're asking how far does the net, how far behind the net does the tennis ball line? So they want now this distance. They want this distance here. How far behind? So let me call this distance. Let me call this distance D. Can I call it D? Obviously D. Let me call this distance L. How far? So this is the distance behind the net from here to here. It's going to be our distance behind the net. But now, what are you going to use there? Now, if we know that from here up to here it's going to be 12 plus L. So we have now the horizontal distance. Now, means that now if we have the horizontal distance in simple terms, our horizontally, so it means that now our SX, okay, our S, okay, we are going to be having U plus half 80 squared. But we say horizontally, or its acceleration is 0. So our SX is going to be UT. Now, what is this S? This S is going to be the distance from here up to here, which is going to be 12 plus D to be equal to UT, where T is the time from here up to here. So, how we have this, how can we get the time from here up to here? So you can get the time because we have this vertical displacement from here up to here. So now, vertically, you can see that our SY, we said, is always given by a half 80 squared. So we have this vertical distance from here up to here. So meaning, if you have this vertical distance, then you can get a time from here up to there, which we need here. So vertically, our SY is 2.8 equal to a half times 9.8, then the T squared, which I'm looking for. So from there, 90 is going to be 2.80 divided by 4.9. Square root of that, we get 0.7559 seconds. So now I have it there, so I can happily now use the time from there. I can use now that time there. Because this is the time, it requires this ball to cover this distance. So it will be the same time it will take this ball to cover that horizontal distance. So I mean that now my 12 plus D will be equal to our U, which is 21. Then times this one, which is 0.7559. So that our D will be now 21, then minus a 12, and our D there is going to be 0.7559. here mindly I'm getting 3.8739 meters. So that's so my D. No, this is going to be okay. Let me call this D so that we don't change a lot. Let me call this distance here a D. So from there up there, from here up here is my D, which I'm looking for there. My distance there is going to be just that. So that's how we handle that question there. So it's going to be 3.87 meters behind the net there. So that's how we handle that, members. I wish you well.